So in this video we're going to be looking at naming alcohols. Now the first thing we got to know is, before we start naming these alcohols, we need to know the general formula of an alcohol, which is given as CnH2n plus 1OH. You could also see it drawn like this: CnH2n plus 2O, maybe, but this is the most common in my opinion. And in naming these alcohols, we're also going to follow the IUPAC nomenclature naming system. So we're just going to start off looking at the simplest alcohol we can, which is going to be methanol. Let me draw this a little bit nicer. Yeah, the OH. And we could commonly define this as methanol. And why that is because here we have a methyl group, methyl, and here we have our OH, our hydroxyl group, our alcohol group, and together they work together to be called methanol. So let's look at another one here. Just gonna draw ethanol here. I'm just using a 3D structure to start off with, but we will begin to use skeletal formula, OH. And here you can actually see we have an ethyl group, ethyl, and here's our alcohol group, our hydroxyl group, and this makes ethanol. So you can see how the carbon-hydrogen structure, along with the OH functional group, come together to form this alcohol. So let's really look into start naming some structures, shall we? So first I'm just going to draw the skeletal formula for a couple of alcohols here. And I'm going to look at some which have maybe more than one alcohol group and how we can go about naming those. So this first one here, we can obviously count the carbon chain, 1, 2, 3, 4. So we know this is going to be butane something. And notice with an alcohol, the carbon part is always ends in "an". So we have methanol, we have ethanol, we have propanol, and here we have butanol. And we can see the oxygen group is positioned in the on the second carbon. Hence we can identify this as butan 2O here. So let's look at the different parts of the name. Here we have the carbon structure, which we obviously name first. Here we have the position of the alcohol group, and here we have the alcohol group itself. So what about this alcohol here? Well, we have 1, 2, 3, 4, 5 carbons. So we're going to have pentan. But we've got 2 alcohols, and they're positioned on carbon 2 and on carbon 3. So simply we can write this as pentan 2, 3 diol, because there's 2 oxygen groups, like so. Now I'm just going to draw out 3 alcohols down here. See if you can pause the video and name these yourself. And, 2 alcohols on this one. Going to make this a little bit more challenging. Oh, we can draw that a little bit better. Apparently we can't. And we'll put an OH there. I'm actually going to put a chlorine here. Alright, so see if you can pause the video and try and name these yourself. So this first one we obviously know is going to have 4 carbons, 1, 2, 3, 4. So it's going to start as butane. Now we know there are 2 alcohol groups, so we're going to have a sort of diol at the end, and they're positioned at carbons 2 and 3. So we have butane, 2, 3, diol. Here we have 1, 2, 3, 4 carbons, but we know this is a cyclic structure, so we're going to have cyclobutane, and my mistake here, because this should be carbon 1, 2, 3, 4, and this OH group is on carbon 1. So here we can see we obviously have cyclobutanol. You could also have cyclobutane 1-ol, but normally the 1 is often disregarded and just written as cyclobutanol. Now we can see we obviously have 1, 2, 3, 4, 5, 6 carbons. So we're going to have hex. So we're going to have hexane something. Hexane. But we also have a chlorine right here, and this is on carbon 3. So we're going to have 3 chloro hexane, and where our alcohol group is, which is on carbon 2, we're going to have 2-ol. 3 chlorohexane 2-ol. Perfect. So the last thing I just want to cover for this video is drawing some alcohols, given that you know the name. So I'm going to write the name of 2 alcohols, and I want to see if you can draw them out and pause the video. So first I'm going to go for maybe 2-methyl propan 2-ol. That's the first one, and the second one we're going to go for maybe something like 2-chloro. I'm going to be harsh here. Cyclohexane 1,3-ol. See if you can name these. This one's quite a challenge, so don't worry if you can't do this one, but hopefully you should be able to do this top one here. So for the top one, you should have started off by drawing just a 3-carbon base here. I'm going to draw these in skeletal formula. Drawing a 3-carbon base here, and we know that there's 1 methyl group on carbon 2, and we also know our oxygen group here is also on carbon 2, OH. And here we can see we have our 1, 2, 3 for propan. We have a methyl here, so 2-methyl propan, and then our oxygen group is on carbon 2, 2-methyl propan 2-ol. And here we have 2-chlorocyclohexane 1,3-ol. Now this is probably going to be a lot easier than you first thought. So first we want to draw our cyclic hexane group, and first I'm going to draw, so we know we start from, this is carbon 1, 2, 3, 4, 5, 6. Oh, I'm not very good at rubbing out here. And I'm going to first draw the chlorine on carbon 2. Then the oxygen is going to be on here. Oh, my bad. That should be diol. Diol. And the last OH group is going to be on carbon 3 here. So hopefully you were able to get these and understand now how to name and even draw some alcohols. Thank you for watching.